Bergson and the Holographic Theory of Mind. Continuing series, part 42, Panpsychism Arising. This will be Philip Goff's version of Panpsychism, which tends toward Russeilian Monism, where we have intrinsic consciousness everywhere in the material field. In fact, tons of little conscious particles. This is a growing reaction to physicalism, the inadequacies of physics to explain consciousness, the hard problem, but it's, in my opinion, desperation in the air. There's still no grasp of their metaphysic, the metaphysic underlying physics, or correlatedly of time. There seems a production line of consciousness theories. All, of course, represent some new attack on the hard problem. Some of it is said, causing new waves in the theory world. None ask, how does this theory explain the image of the external world, the humble coffee cup being stirred? If they are asked, they collapse. None can spell time. None think how or whether the brain even stores experience, that this might be a problem. None think Bergson existed or worthy of an erg of attention. So we come to yet another. Panpsychism is, of course, not new. It has already had its exponents in and before the debate, the hard problem debate. Whitehead, Scribina, who wrote that book, Panpsychism in the West, which details the whole history thereof. We're not going to go through that whole history. Strawson, a recent proponent. I've explained that Bergson's theory is panpsychic, but a unique version thereof that's not paid attention to by the panpsychic guys, with considerations so far beyond these guys as to make them look, well, to me, like kindergartners. But Bergson does not exist to these guys. So a new exponent has caught my attention, Philip Goff. He's done lots of YouTube talks to try to popularize this version of panpsychism. He has one book, the Consciousness and Fundamental Reality 2017 book, and one coming, Galileo's Air, which he says is more popular, less difficult than the 2017 book. His hero, Bertrand Russell, and Russeilian Monism, which we'll get to. As with the idealists, who we already have covered, Hoffman, Castro, this is a reaction and growing to what they define, in my opinion, very inadequately as physicalism. That is, the world as featureless billiard balls, billiard ball-like particles. Bergson was way beyond them in 1889. So Philip's very interesting starting point is Galileo. To quote, before Galileo, people thought the world was filled with sensory qualities. The spiciness of the paprika is really in the paprika. The smell of the flowers is really in the flowers. Colors are really in the surfaces of objects on the flower. But the problem is, it's hard to see how you can capture these kinds of qualities in the purely quantitative language of mathematics or computer programs, same thing. How can you capture in an equation what it's like to taste paprika or see red or violet? Galileo answered this challenge with a philosophical theory, a reimagining of the universe. According to his reimagining, the sensory qualities are not really out there in the world. They're just in the soul of the perceiver. So our guy there looking at the table, all the qualities of that table, the browns, the smoothness of the surface, the smell of varnish, that it's hard, are in the mind. By the way, I think that guy is my 1970s Marine Corps exit version thereof, but won't worry about that. So the crucial point, he says, is that Galileo at least never intended physical science to be a complete picture of reality. He thought it could describe the mathematical quantities of the physical world, but not the sensory qualities, which he took to be forms of consciousness. So the mathematical qualities, the length, the height, even the geometric qualities or quantities, the squareness, the form, in other words, of the table could be handled by science. So what you get is a breakdown, primary and secondary properties. On the left, the secondary properties, these are in the soul of the perceiver, or in the mind. On the right, the primary properties are in the table, size, length, breadth, width, or its form, mass. And these primary properties can be captured in the purely quantitative language of mathematics. The moral: physical science has done incredibly since Galileo set the rules. This does not imply physical science can handle qualities. In fact, says Phil, Galileo, should he return, would say, of course science can explain qualia. It was never intended to. Hence the problem with the hard problem. Even should we accept this distinction, primary versus secondary properties, and many theorists would, it still doesn't work. Perceived form is dynamic. It's not computable. It's probabilistic in optimal specification. The values are indeterminate. Remember the strobed rotating wire edge cube. Strobed in phase with a symmetry group, it's a rigid object, a rigid cube. Perceived as a cube. Out of phase, it's a wobbly, plastically changing, not cube. Or the rotating ellipse. Those velocity vectors, if it's moving too fast, turn the rigid ellipse into a wobbly, plastic, not an ellipse. So form, shape, despite what Galileo said, despite this distinction, is in reality equally qualia. Again, what we have and what we're ignoring is that these are invariants over time, over continuous flow. The Gibsonian cube there, rotating, its edges, vertices, are sharp discontinuities at junctures of the flows, invariants at the flows. So what we have is the time problem recognition failure in this whole notion of form. But forms fill the image of the external world. It's why the whole image of the external world must be accounted for, because forms populate that image. You can't compute the forms in the image. See, that's taken care of, and then just have to worry about the qualia, the colors of the things and whatever in the image. It kind of goes back to Berkeley here, critiquing Locke's distinction of, again, the same thing, primary versus secondary properties. To him, not comprehensible, not coherent. What is a form without color? It's nonsensical. Can you compute the form of a gray cube, but not a red, blue, or green cube? Gray isn't a color. This is incoherent. This is what this whole collapse of secondary and primary properties is actually keying on. It's partly why the hard problem is misstated, however, not understood. Philip now introduces Eddington and Russell. Their starting point is, to quote, physical science tells us, or tells you a lot less than you think about the nature of matter. But what Russell and Eddington realized is that, due to the nature of mathematics, science cannot tell us what physical properties are. The mathematical characterization of physical properties is circular. So we'll take a simpler equation than what Phil has on the board there, which the gravitational equation, which is simply take force equals mass times acceleration. So that's force, but then what's acceleration? Well, it's force over mass. But what's mass? Well, it's force over acceleration. In other words, all terms are defined in terms of each other. It's circular. To quote, physics is just not in the business of telling us what physical properties are. It just assumes them and tells us mathematical relationships between them. For Eddington, physics is a tool for prediction. So all the successful predictions it makes look great, a tremendous aura of knowledge. And yet, physics is doing great precisely because it is ignoring what everything is. In other words, physics is only in the business of discovering invariance laws, like I've been saying for a long time. It is amazing, though, how little this is understood and the resistance to it. Now, I have noted in number 9 in Free Will that Bergson had already been here in 1889, discussing the concept of force and the physicist's notion thereof. He had noted that The physicist is careful to express this only as a relation among magnitudes, F equal ma. That is, it's an invariance law. This was in the context of the origin of force as a cause, as something that makes things happen, that moves billiard balls around, as being a derivative from our psychological experiential being. That is, force itself is a phenomenon of a physical, psychical, universal field. But physics does not touch this. It's limited to invariance laws. That is, it's already where Goff is going to go. This will relate to a larger context that will get developed as we go. We see Philip using the gravitational equation for force in his example of the circularity, the lack of definition of properties. Let's drive this in with a quote from Newton on this. He was hardly unaware of this problem. To quote, "It is inconceivable that inanimate brute matter should, without the mediation of something else, which is not material, operate upon and affect other matter without mutual contact." Now we have a fine example of mutual contact there. "As it must do if gravitation, in the sense of Epicurus, be essential and inherent in it." And this is one reason why I desired you would not ascribe innate gravity to me. That gravity should be innate, inherent, and essential to matter, so that one body may act upon another at a distance through a vacuum without the mediation of anything else, by and through which their action and force can be conveyed from one to another, is to me so great an absurdity that I believe no man who has in philosophical matters a competent faculty of thinking can ever fall into it. Gravity must be caused by an agent acting constantly according to certain laws, but whether this agent be material or immaterial, I have left to the consideration of my readers. Newton to Bentley. Thus a glimpse of why I tend to veer away from the current physics in the attempt to further develop Bergson towards theorists like Wheeler, Dollard, with intrinsic roots in Heaviside, Thomson, Steinmetz, where we see what it looks like to actually understand these properties, like Wheeler's drawing of a magnetic field with a dielectric inertial plane, etc. Bottom right there. So, okay, this is essentially the end of Phil Goff's expression of the current attack on and distaste for physicalism. But before he gets to panpsychism, let's ask, what have we not seen? What we've not seen is any real understanding of the classic metaphysic, the metaphysic at the base of all of this. Particularly, we've seen a complete unawareness of the problem of time. Bergson was aware of this entire problem. His basis for reaction, expressed in 1889 in Time and Free Will, was Herbert Spencer. Spencer had crystallized, codified the classic metaphysic underlying science, the big thing of the day. And so was Spencer. Note the 10 volumes of synthetic philosophy. To Spencer, time was to be treated as if it were little different from space. Like space, time is measurable and contains juxtaposed parts. Like space, it is a homogeneous medium whose parts and properties are everywhere alike. So we're getting to my favorite little picture of time as a series of instants of the all of space, where each instant has the time extent of a mathematical point, or the all of space at an instant, a mathematical point in time extent, and each cube is utterly homogeneous. There are no qualities within those cubes. Like space, then, it is capable of being measured by mathematical concepts, and one can see that one time is equal to another, or twice as long as another. So cube 1 and 2 there are twice as long as in time as cube 3. And finally, it is meaningful to say time is composed of instants. The movement of time, a series of instants. As a body moves from point to point in space. I've noted before that space is a continuum of points or positions. It's the abstract space or continuum of points and positions, a three-dimensional continuum of points. But as the body moves, each point coincides with an instant of time. Time is then just another dimension, the fourth dimension of the abstract space. All this is the classic metaphysic. But to his surprise, Bergson found that this common sense and well-accepted view has held little validity. The most cursory examination revealed that moments of time are not alike, that each has its own quality, nor do instants ever simply repeat or simply occur in succession. Rather, there's a continuous flow where each moment merged into the next. And thus, as we have seen, Bergson was to describe a far different time, as lived by the self, our consciousness, a time he termed duration. To quote, below homogeneous or abstract time, which is the spatial symbol, spatial version of time, spatial symbol of true duration, a close psychological analysis distinguishes a duration whose heterogeneous moments permeate one another. Below the numerical multiplicity of conscious states, a self in which succeeding each other means melting into one another and forming an organic whole. Now, by numerical multiplicity, we take 3 apples, that's a numerical multiplicity. It consists of 3 distinct units. The apples have been unitized, all their qualities are ignored, etc. But conscious states are not such distinct units and entities. They can't be considered a numerical multiplicity. They're an organic melding into one another, an organic whole. Again, he likened this to a melody where each note permeates the next. Each note reflects the entire preceding series. So physical time, as described by Spencer, could only be the limiting case of this real time, this concrete time or duration. But such a time entailed the rejection of Spencer's mechanism. For mechanism, read physicalism, the physicalism that Phil has been attacking. If mechanism was correct, all change, all motion is reducible to the completely predictable motions of material particles, and free will is an illusion, just billiard balls clashing into one another deterministically in the brain. But the experience of duration showed that change was far more dynamic, organic, and interrelated as a process than could be supported by the motions of particles. The present could not repeat the past. Each present moment was poised before novel possibilities. Mechanism, again read physicalism, was wrong, both in its account of change and its assumption of simple prediction, like Laplace, where given the states of particles, I can predict the entire universe, state to state to state. But where is any of this in Goff? Still, after 130 years. A symptom, all its qualities are static. The taste of paprika, the smell of coffee, the color red. There are none of the dynamic, time-flowing qualities of Hardcastle, the audience shifting in their seats, the musicians concentrating, the curtains ever so gently waving, or make the rose blooming, the coffee stirring. Time is not mentioned. There will be no progress until spatialized time, the true problem of the classic metaphysic, is grasped. So Philip says, there's a gap in physics. We don't really know what physical properties are, as we've seen. It's a problem of intrinsic natures. We know how an electron behaves, but what is it? What truly is the electron, or what truly is force? And how does this relate to consciousness? If a gap in physics, there is one in neuroscience. Because properties of the brain, says neuroscience, are really in terms of chemistry. But chemistry, in turn, is in terms of physics. But then we're right back where we started from, back to the problem. We don't know what brain states truly are. So we have this huge gap in our understanding of the brain. Eddington's insight is that we have this gap and we're looking for a place for consciousness. Let's fill the gap with consciousness. Russeilian monism, roughly the same thing. Conscious states are the real nature of brain states. Example, Phil uses a C fiber fires and there's pain. The feeling of pain is the real nature of the C firing. This was the genius of Russell and Eddington. They combined the problem of consciousness with the problem of intrinsic natures. The intrinsic nature of the C fiber, being conscious, somehow accounts for the pain. So physics tells us how particles behave, but in their intrinsic nature, they are unimaginably simple forms of consciousness. This essentially solves the problem of consciousness by finding there's a place for consciousness in the workings of the physical world. Now, is this truly genius? I really don't think so. Let's take a time out. There are two fixations here, the particles and the brain. Let's start on the particles. So the little billiard balls are conscious, but we're still stuck in the classic metaphysic. Bergson, noting the notion, the concept of objects and motions, the motions of objects, declared this to be a fundamental partition in the universal holographic field made by our perception, for the sake of action by the body, to grab a bottle, to shake a rattle. Rather, he said, the field as a whole is changing like a kaleidoscope. Objects and motions are in reality changes or transferences of state in the global motion of the whole, like waves. He went on to ask, what is a particle but the extension in thought of this bodily perceptual process by which useful objects, bottles and rattles, were first identified in the whole? It is a concept derived purely from practical action, which will never, imported into the realm of pure knowledge, explain the properties of matter. He says, but the materiality of the atom dissolves more and more under the eyes of the physicists. We have no reason, for instance, for representing the atom to ourselves as a solid, rather than as a liquid or gaseous, nor for picturing the reciprocal action of atoms by shocks, like the billiard ball, rather than in any other way. Why do you think of a solid atom, and why of shocks? Because solids, being the bodies in which we clearly have the most hold, are those which interest us most in our relations with the external world. Between these particles, we envision forces of attraction, ultimately even a gravitational effect between all objects in the universe. Something then exists between the atoms. It will be said that this something is no longer matter, but force. And we shall be asked to picture to ourselves, stretched between the atoms, threads which will be made more and more tenuous until they are invisible, and even, we are told, immaterial. But what purpose can this crude image serve? And what happens to this image? And indeed, we see force and matter drawing nearer together the more deeply the physicist has penetrated into their effects. We see force more and more materialized, the atom more and more idealized, the two terms converging toward a common limit, and the universe thus recovering its continuity. The Russeilian monist hasn't gotten here yet, but it's only been 120 years. Per Goff, the particles are conscious. A mass of them comprise the brain. Now we can understand brain states. That is, we'll focus on brain states to understand phenomenal experience. the coffee being stirred. But we, that is Phil, just got done destroying Galileo, his primary and secondary properties distinction. This distinction no longer applies to the entire material world, not only to brains. The entire universal field is qualitative. It has both primary and secondary properties. These cannot be logically coherently separated. Roses, tables, coffee cups, qualitative within the qualitative field. So why have you fixated on the brain and then trying to figure out via some form of emergence, as we'll see, how the brain with its mass of conscious particles generates the image or an image of the coffee stirring? Why not this focus instead? How does the brain specify an image of qualitative aspects of the already qualitative external field, right where they say they are, within the field? This was Bergson's question. The significance of matter and memories, Chapter 1, and Gibson's question 2. Why not? Why not this focus? Because in reality, they, our friendly panpsychists, are still stuck in the featureless billiard ball particles that happen now to be conscious. Let's go to one cause thereof. So Bertrand Russell, sorry he's not that impressive, and carries this, the DNA of blindness on time, which he seems to have transmitted. Russell happened to be one of Bergson's greatest critics. He sought to recast Zeno's arguments, his paradoxes, into an arithmetical framework, but Russell's resolutions to the paradoxes are most curious. To begin with, Russell, probably to Zeno's amazement, agrees on the facts of the arrow paradox. Remember, the arrow paradox is the arrow moves. It's always coincident with a static point along the line that space has been divided to, point after point. So it never moves. The arrow never moves. To quote Russell, after 2,000 years of continual refutation, these sophisms were reinstated and made the foundation of a mathematical renaissance by a German professor who probably never dreamed of any connection between himself and Zeno. Weierstrass, by strictly banishing infinitesimals, has at last shown that we live in an unchanging world, and that the arrow, at every moment of its flight, is truly at rest. The only point where Zeno probably erred was in inferring, if he did infer, that because there is no change, therefore the world must be in the same state at one time as at another. This consequence by no means follows. How an unchanging world can be different at successive moments, Russell does not explain. We're back to the instantaneous cubes of the all-of-space model of the transformation of the universal field, where there's ever only one cube. Nothing exists but that one cube, and where each cube has the time extent of the mathematical point. And where, since each is frozen, there is no way to explain the transition to the next changed cube. There's no way to explain change. And where a background continuous process is implicitly assumed, which is regenerating the entire universe, cube after cube after cube, with each cube as a slight change from the previous. At its essence is the assumption Zeno relies upon, that time is just another form of space. Somewhere, critiquing Bergson's notion that motion must be treated as indivisible, Russell states there can be a staccato process, right? Because what we're looking at there with the cubes is a staccato process, which is incoherent. Russell proceeds to resolve each paradox. That is, he resolves the first three. Zeno's fourth paradox, absolutely untouched. In this paradox, Zeno asks us to imagine a body B in the middle there, moving at a certain speed. It passes two other bodies, one at rest, A, one moving towards it at the same speed, body C. So that's the start of the instant. End of the instant, they've moved. B moving one direction, C to the other, A is still stationary. During the same time or duration that B passes a certain length of the resting body A, it passes double the same length of the body C moving towards it. So it passes a length D of body A, but it passes the length 2D of body C, or a distance D and 2D. Zeno concludes that a duration is the double of itself. Russell's resolution is to agree that this has its exact analog in the arithmetic paradox he has developed. As far as the time aspect of Zeno's argument, Russell states, the best we can say is that at one instant the bodies were in one alignment and in the next they were in another, and that we cannot say what happened in between. Again, back to the magical cues of the all of space transition model. Can't say how we got from space 1 to space 2 to space 3. That is, he accepts the paradox as valid. In point of fact, Russell left the core of Zeno's conundrums untouched, strewing problematic statements about time along the way. He was to further backtrack and alter opinions in 1911. It is an unfortunate fact that Bergson's resolution has been in the meantime neglected. It was held consistently throughout his works. The paradoxes arise from the false assumption that motion and time are divisible in infinitum, or infinite divisibility. This assumption is based on the confusion of the movement itself with its motionless track in space. So each of these guys moving leaves a track, a trajectory. Again, just another representation of the movement across or through the continuum of points and positions, infinitely divisible. It is this track that is infinitely divisible, a divisible line, a space of points. Again, the infinitely divisible continuum or space, abstract space. To quote at bottom, the illusion arises from this, that the movement, once effected, has laid along its course a motionless trajectory on which we can count as many immobilities, that is, static points, as we will. From this we conclude that the movement, while being effected, lays at each instant beneath it a position with which it coincides. We do not see that the trajectory is created in one stroke, though a certain time is required for it, and that though we can divide at will the trajectory once created, we cannot divide its creation, which is an act in progress and not a thing. It is the trajectory Zeno contemplates in the fourth paradox, totally consistent with his assumptions, and of the same fabric with the other paradoxes, which, when he declares a duration the double of itself, whatever sense that makes. It is the trajectory of Achilles we can divide, but not his motion. Each of his steps must be construed as indivisible, and so must those of the tortoise. They are not decomposable at will. The movement of the arrow is an undivided fact. It never, in fact, rests at some point along the way. Time, the very motion of the universal field, transformation of that field, is not space. This simple statement makes all the difference, but it is the difference that has utterly escaped Goff and the panpsychic theorist. And I note there on the right, I've discussed the invalidity of the so-called mathematical resolutions in video number 3 and in Collapsing the Singularity. Now, Bergson spoke of the universe as the aggregate of images in Matter of Memory, chapter 1. For all we know, is an image of the thing, an image of a tree, a butterfly, a cup, even atoms, not the thing in itself. It's like Hoffman's icons. The picture of the wastebasket. Underneath that wastebasket is all kinds of code that does the actual thing the wastebasket does. So a bit of an analogy from Hoffman there. Kastrup agreed with this. But for Bergson, this image mode is but one mode of describing the material world. The skeptic of Bergson will say, well, what does he mean by image? Surely this is some idealistic view. Looks like Hoffman, Kastrup, etc. Like Sartre, the skeptic has failed to see Bergson's other mode, the holographic mode, where again in chapter 1, discussing where the brain has no photograph of the coffee cup inside, he said, isn't it clear that the photograph is already developed in the very heart of things and at every point of space? That is, he's pointed to the holographic nature of the field, the material field. And this whole field is a whole transforming, as we noted, indivisibly. And then we can see in retrospect, he was essentially saying that the brain is a modulated reconstructive wave passing through this holographic field and specific to a part of the field, the coffee cup stirring now by this process in image, part of the field at a scale of time. Buzzing fly at a normal scale, wings a blur, raised energy state of that reconstructive wave / brain, perhaps a fly flapping his wings like a heron. But ray images then, Russell falls into the same trap. He calls this Bergson's, quote, very unfortunate debt, unquote, to idealism. His evaluation of Bergson's philosophy begins and ends with this commitment of Bergson to the idealist camp. But wrong. This is a total fail. The image is in the field, not in our guy's mind there. Bergson was not in idealism. He sought an intermediate place between realism and idealism, where properties, qualities, perception itself are not just in the mind, or idealism, or Berkeley assigned them, but in things within the holographic field. And as opposed to realism, the matter field is indeed qualitative, not a pile of featureless balls, billiard balls, from which it is impossible to restore or derive quality. Nevertheless, things are out there, external, in the field, as per realism. But all this depends on time as an indivisible motion, and the holographic field is transforming indivisibly on his resolution of Zeno. All of which beyond Russell, and still beyond his descendants. In the burial of Bergson, Russell was one of the figures who's seen Sartre, even Heidegger, as just a couple of others. There's a piece of background with respect to the times, something to be considered. Bergson was enormously popular. Women flocked to hear him. French papers debated if he should remove his lectures to the Paris Opera Hall. When he came to the United States, the crowds were overwhelming. They dwarfed the crowds Russell got. The popularity engendered academic envy, kind of a backlash. I'll put a link to this article in the description. This did not help the state of mind required to penetrate his extremely profound, prescient vision, thus the failures. And they criticized his use of metaphor, along with this critique. Yet we have seen that all thought is based on analogy and metaphor. Bergson's writing was very metaphoric to try to illustrate the points. But see Hofstadter and Sanders surfaces in Essence's book their mockery of academics who, using metaphor profusely while making the critique the use of metaphor. So back to Phil. He notes certain levels. The micro level, the physics level, with particles characterized as behavior, mass, charge, the invariance laws, but intrinsically simple forms of consciousness. Then there's the chemical level, a higher level, compounds characterized in terms of behavior, but intrinsically conscious. And then there's the neural or neuroscience level, brain and brain states in terms of behavior, but complex forms of consciousness. All this leads to panpsychism. Philip now addresses the combination problem, the famous panpsychic combination problem, how you get phenomenal consciousness, the coffee stirring, the whole phenomenal experience of coffee stirring from a mass of conscious particles or billiard balls. So first, one approach, reductionist panpsychism. This tries to explain human and animal consciousness in terms of particle consciousness. It's something like how the chemist explains the properties of water in terms of H2O molecules. Knowing H2O, he says, we get a completely satisfying explanation as to why and how water boils. So he notes physicalism to explain qualities is intractable, but this reductionist panpsychism, that's tractable, but it may take decades or centuries to discover all these laws and principles by which we get the coffee cup. One wonders, does the reductionist program even explain water? Search the question on Google. What is the difference between water and H2O? The first answer that comes up on Quora, kind of interesting. The idea that water simply is H2O is one of the false reductions that people can't seem to get out of their heads. What is actually true is that if you break apart the bonds in water, you'll get a ratio of hydrogen to oxygen that's roughly 2 to 1. A very large amount of this will be from H2O, some from OH, some from H3O, etc. And it is the overall interaction of these, not just properties peculiar to H2O, that give us what we call water. Because the properties of water arise not from the molecule, but from constant widespread dissolutions and reformations of H2O and related molecules. This is kind of a non-answer and typical. The rat says maybe we should have asked Feynman. I think he's thinking about Feynman's attempted explanation of magnetism, which didn't go well either. One could ask, does the appeal to widespread dissolutions and reformations of molecules actually explain how H2O becomes water, H2O to water transformation? I'm just saying that this is, I suspect, kind of a mythology. I haven't looked into it that much, but this is how I've always tended to think about it. It's kind of a myth. It's kind of the same case as trying to derive qualities from the billiard balls. It's kind of the hard problem of physics, more mundanely. Philip's favorite, kind of, he has reservations about this, is Emergent Pan Psychism. He says almost all theories of consciousness have a serious problem at their core. One theory doesn't. Emergent is panpsychism. This posits fundamental laws of nature to bridge the gap from particle consciousness to systems or brain-level consciousness. They hold that when you have conscious particles arranged in a certain kind of system, the system as a whole becomes conscious. That's just a basic fact about our universe in this proposal. To quote, because they appeal to fundamental laws, the emergentist panpsychist doesn't have a gap to bridge. They don't have to explain how we get from particle consciousness to brain consciousness. Why not? Because fundamental laws, by definition, cannot be explained. So we simply explode the gap. There's no gap to bridge. But we just said there's a bridge to gap. Now, this might kind of seem sniggly, but it kind of holds a hidden difficulty. But we'll move on. The EP, the emergent panpsychist, according to Phil, just has to get on with the empirical task of working out what those laws are. This is being done, he notes, by Hedda Hasselmark, who worked with Tononi on IIT, Integrated Information Theory, which we discussed in number 35. In this theory, consciousness is correlated with maximum integrated information, Tononi's phi number. And we have a phi up in the corner there that's equal to a sponge, but that's because we're dealing with the phenomenal experience of SpongeBob there watching the coffee, and we don't have much of a complex system. It would be a much more complex system and a rationally derived number. But in Tononi's view, it's a correlation view, that consciousness is correlated with maximum information. What Merck does is take IIT and combine it with Emergent Pan Psychism. The result is a fundamental law of nature that in any system there is consciousness at the level in which there is most integrated information. So, of course, as we noted, there's a question of what is information. And we noted that this is not a solution to the origin of the image of the external world. Firstly, it's still just neural activity. That is to say, it's very complex. It's supposedly computing or characterized by information structures and complexity thereof, but it's still just neural activity. And if you're appealing to complexity, you're already appealing to an implicit form of emergence. But it's ignoring as well the invariance structure of events. There's no way that these bubbles or compositional elements are reflecting the dynamics of this event over time. The velocity flow fields, adiabatic ratios, inertial tensors, haptic flow fields, texture gradients ratios, flows. These bubbles, compositional elements, are furthermore derived by no particular principled method. It's again one of these attempts to break down an event where there's no particular principled method. It's almost as though we're back to a geometric form where we're trying to imagine a geometric form with no color in the lines, but one can't separate things out that simply. But it's even worse than that. And again, what we're dealing with is in reality an image, a pile of neurons giving birth to an image. The complexity notwithstanding, it's an image giving birth to an image. In this case, the coffee cup. That is, you have two things of the same order. Both images, the coffee cup, the neurons. You could drive the neurons down to atoms. They're still images. This is the problem that the idealists are worried about but don't quite get. You can't derive images from images. You can't give birth from one set of images to another set of images. Yes, it's that discussion of images in Matter and Memory, Chapter 1, that Russell failed. Hence, Bergson went to the holographic field, which is non-imageable, and in essence is the things in themselves within that field, and that field of massive interaction, which is unimageable. And what you're doing is deriving, in Bergson's model, images from this holographic field, not from images. I noted that Tononi and IIT is in reality an emergence theory already. In a video by Michael Silberstein I discovered, I thought it interesting because he noted panpsychism needs emergence theory and emergence theory needs panpsychism. Why? Because physicalism needs the little thingies from which consciousness emerges to be, intrinsically conscious, like Eddington and Russell. And panpsychism needs emergence from the mass of little conscious thingies. And no one knows what proto-conscious thingies actually means in the first place. That's another small problem in this, but we're giving them that. So what Silberstein calls the master argument actually going on here, well, as we've seen Goff argue, physicalism can't solve the hard problem. This is being understood. So emergence plus panpsychism, marrying the two, is the next most conservative alternative. Hence, this is the direction we're going. Not that it's brilliant or genius. So the panpsychic emergentist folks say they've solved the hard problem. Nope, not even close to addressing the origin of the image of the external world when put that way. I'm going to recap this statement once more, the origin of the image of the external world, as I just got a comment on number 41 on Kastrup's idealism from a suspected academic to this effect. How can you say that the hard problem is the origin of the image of the external world? That's not the hard problem. Here, look at the IEP, International Encyclopedia of Philosophy. It's a peer-reviewed academic source. And of course, you look at the IEP, and the hard problem is all about explaining qualia. How do qualia emerge from computer architectures or neural architectures? He goes on, why, in my opinion, accounting for the image, that would be easy. Right. Standard misconception. The hard problem has nothing to do with the image, just qualia. Yes, stirring the coffee is filled with qualia. Browns, creams, clinks, aromas. It's also filled with forms, spoons, cups, tables, hands, and the forms are not computable. They're equally qualia. Further, the event is time extended. It is a continuous flow. We see the stirring, the swirling. These are qualia defined over time. These forms, like Hardcastle's gently waving curtains, patrons shifting in their seats, dynamic form, not computable probabilistic specifications. So this too must be explained, the time extent, and this ties to the profound problem of the nature of time. So you better have some thoughts on the nature of time, of which there are none. So the entire image of the external world must be explained. The forms which fully populate it, its dynamic time extent, not just its qualia, as this term is currently narrowly, that is timelessly, and very inadequately understood. This is to say, what I've just said, is already the more complete, the more full statement of the hard problem, the origin of the image of the external world, the entire image. But there's more. Once it is realized that it's the image of the external world that must be accounted for, the problem of subject and object is naturally intrinsically entailed. You cannot have an homunculus, the little man in the brain, viewing the image. That this is not understood is given away by this. No hard problem theorist I can think of treats this difficulty of subject and object, this relation. Certainly not Chalmers. To state the problem correctly is to see its solution. Because guys create philosophy entries on Wiki or the IEP does not mean that they see the problem correctly. The theoretical performance on the hard problem to date should be sufficient evidence that the problem is not understood, that it's not stated correctly. A short intermediate postscript here in this exchange. Unfortunately, even explaining this, the actual nature of the problem of the external image and therefore the hard problem, explaining this to my commentator and defender of Kastrup meant diddly. The thing is, if your thing is idealism, you just say, I still can't see a problem. The image of the external world is just a thought of the TWE. That is that which is Kastrup's cosmic mind. So you can see why this guy thought explaining the external image was easy, not a problem. Neurons, not needed in reality. The phenomenal coffee stirring, the phenomenality thereof, just a TWE thought. We go directly from neural activity or computer activity that Chalmers thought was so hard to move to qualia and say, easy transition. It's now just TWE thought or cosmic mind thought. If neurons had never been discovered, idealism wouldn't care. It doesn't need them. This is the dirty little secret of idealism. Given you can simply appeal to the thoughts of God, there are no constraints. You can explain anything. This is an implication of Kastrup in number 41 I never quite explicated. He was implying he could explain all the mysteries of quantum mechanics, all these strange things, by simply appealing to his cosmic mind. All QM phenomena can be explained by thoughts of the TWE, which I think would be amusing to physics. And the hard problem solution I'm using to neuroscience. In Phil Goff's and his monism's favor, at least, they recognize the need for constraints on thought and explanation. They're at least looking for laws. So again, the panpsychic emergentist guys say they've solved the hard problem. Nope. And the list of things not considered, as usual, is enormous. The perception of time-extended events, the scale of time of events, the role of invariance laws defining the events, the relation of subject and object. Is experience actually stored in the brain? What is explicit memory? Why is consciousness needed for cognition? Language understanding, analogy, and common sense knowledge, all related to the problem of consciousness. So I would say panpsychism, given this, well, kind of becomes the pumpkin. So Philip represents an increasing awareness of the problems of physics and physicalism, but not of the classic metaphysic beneath it all. Secondly, the standard complete failure to even consider Bergson, who had been there, as we've seen, and way beyond, way before these guys. Incredible. When one looks at this book of Phil's, the consciousness and fundamental reality book, the index, just looking at the index for start, says much. These are the people tend to be listed. Armstrong, Blackburn, Bloch, Carruthers, Chalmers, Churchland, Dennett, Nagel, Nita, Rimelin, Papineau, Putnam, Rilofs, Russell, Seeger, Strawson. It goes on like this, basically contemporary or fairly recent philosophers. And subjects, the anti-subject summing object argument, a posteriori identity, austerity problem, causal exclusion problem, compositional nihilism, conceivability, disposition, distributional property, essence, less essential, fusionism, fundamentality. And it goes on. The problem, this is a somewhat ingrown philosophical community speaking to themselves, to what they regard as the problems. Philip says he loves neuroscience, follows it closely. But what he also needs to love, perception, ecological perception, particularly Gibson, but other perception theories as well. Cognition, developmental cognition, Piaget, all 20 of his books, Wertheimer, Hofstadter, Sander, the whole problem of language, memory, the whole field of research and theory, where Bergson began his analysis and research for 5 years on the fundamental question for consciousness as to whether experience is stored in the brain. In fact, Bergson was worried. 2 of the 4 chapters in Matter and Memory are devoted to memory research and problems, phenomena of memory. Would the philosophical community have the patience or interest to read it? Well, I think the problems still exist. These guys seriously need more constraints on their thought. While absorbing the above fields, they should be asking, well, how in the heck can the brain be doing this? Doesn't a theory of consciousness need to be able to cover this too? Just saying, things might change. So next, we'll see. Till then, signing off.